Okay, so data processing. If you open up this day one, number 2 data processing.r markdown file, then you're going to see these so-called chunks, which are in gray. If you're not familiar with R markdown, then you can mix text and code together. And there's this little play icon. So you don't have to run line by line. You can just click on it and run the whole chunk together. I was trying to make the chunks really small so that once you run a chunk, then we can stop and talk about what we were doing. And because I already run 2 lines, I'm just going to load this MIFA4 library, which we are going to use for data manipulation, and the data set, which sits in that data folder. So let's create a little dummy data set. It's a data frame. We are going to call it D. And as you can see here, I just printed the structure of it using this str method. You can see we have 4 columns: sample, species, abundance, and behavior. This is not a huge table, so I might as well print the whole thing. You see sample 1 and sample 2, couple of species: black-throated green warbler, ovenbird, Canada goose, robin, and the abundance, that is the count, and what kind of behavior was observed. Was it heard or seen? And oftentimes this is not the format we want the data in. We want a nice tabulation of these counts, having samples as rows and species as columns. So with this a little function, xtab, the name implies cross tab, we want to tabulate abundance with samples as rows and species as columns, and this is the output we get. As you can see here, this is a sparse matrix, and the sparse matrix is very similar to a dense matrix. The only difference is that instead of zeros, you see these dots, and that is just to remember that a sparse matrix representation doesn't store the zeros. So this way, it is a lot more compact representation of the data. And why I tend to use sparse matrices is because I'm dealing with large data sets, so just kind of saving on memory. But also, point count data tends to be really sparse. And by that, I mean it is usually 3 to 5% of the data that is not a zero in a huge matrix of many species and many surveys. So that's why I found that this is usually a good idea to store counts in some kind of sparse matrix representation. It is also referred to as a wide format table, cross table, pivot table, two-way table. And another important aspect of bird data sets is there has been some changes in R recently with version 4, when the default of reading in a CSV file and working with data frames changed with respect to storing character information as factors versus plain characters. So what that means is here you see the class of the sample and the species column, and also the behavior is factor. And it has 3, 4, and 2 levels, but it is still just some numbers. So you get to combine together these labels, heard and seen, with the index of those labels. So if you see 1, 1, 1, 1, 2, that means heard, 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 seen, because those are the labels, and these indices is just how you repeat those labels. Now, if I turn those into character, then what happens? So in our original table, we had 3 samples and 4 columns. Now in these lines, I just turned sample and species into a character representation. And now I only have 2 rows. Why did that happen? That's because if you look at the data, how we originally specified it, we had 3 levels, but only 1 and 2 occurred in the data set. Still, S3, that was that label which we didn't have a row for, that just meant in that sample we detected nothing. And because this way you can get rid of those samples when you went there, waited 5 minutes, you heard nothing, that is still a data, that is still information. At that point in that time, you couldn't detect any species. So we want those zeros in our data set, and kind of just reading in a file and getting rid of these information, especially after subsetting the data, this is really dangerous. So you want to be aware of this. And then also if you further subset the data, which is this next line, give me just Ovenbird, you even drop sample 2 as well, because Ovenbird wasn't observed in sample 2. Luckily, there are different ways, either to just learn how to deal with factors, and then subsetting the table won't really affect this. So if I run the same kind of line, but using the original input D, where things are still factors, then you can see this one column has all the samples, 1 detection, 0, 0. And at the end, you might still want to work with the data as an ordinary matrix, because that's what we are used to. And that's really easy to achieve. You just say s.matrix y, which is a sparse matrix. This is now a dense matrix version of that. You can see zeros are now zeros. Okay, let's skip a few of these and just go to this xtab3 chunk where we look at the subsetting. So why I also found this xtab to be really useful, you can do something like this. Give me only one behavior versus the other. The structure of the 2 matrices is identical. You have the same rows and columns, but the cells are now referred back to those behaviors. So by subsetting, you're going to take the first 4 rows, put these counts into the matrix, but still you use all the factor levels as row and column names. And so this just makes it really easy to deal with slices of the data. We are going to see that we have multiple time intervals, multiple distance bands, and how to have those information separate, but still refer to the same sampling events and species. So this is going to be quite important for removal modeling and distance sampling. So what you can often see in point count databases is something of a placeholder. So there is a species code none, which doesn't refer to any real species. That's just a placeholder for a sample when we detected nothing, so that it's still going to be part of the table and we are not going to get rid of it just by accident. Because if you run this, then you'll see D3. Now we have sample 3 coded species as none, 0 abundance, and we can leave behavior as NA. This way, even if a sample is treated as character, you're going to retain that information. So this is the safest way that people have used in the past quite often. If it's called something else, it is still often documented in the database description or metadata what those names mean. But none is quite prevalent, especially when working with these 4-letter species codes. So now some exercise for you. Use this same D or D3 data sets and try to make different cross tabulations using other subsets. And then also, once you have something like this, Y, try to access different subsets, for example, Robin. Then you see one dimension is dropped. How to retain that is say, please don't drop it. So try some of these to get familiar with these indexing. And also when you are making this xtab call, something that we did before, try to figure out what this R drop and C drop arguments might do with the data. These are just for convenience, but you will see how it impacts the output. Now, you might wonder what this is. This formula that we use in xtab, there's a left-hand side, left to the tilde, and the right-hand side of the formula. And we so far have used abundance tilde sample plus species. See what happens when you drop the left-hand side and say only tilde sample plus species, and what happens when you put in something like a third term into the right-hand side, say behavior. If you try a fourth element, it is going to give you an error. So you can have 2 or 3 terms on the right-hand side, 0 or 1 on the left-hand side.